In this video, we're looking at similar triangles and be able to prove that two triangles are similar. First, to understand that two triangles are similar if they meet the following criteria. That one, the corresponding angles are equal, and two, corresponding sides are in the same proportion, so the same ratio. And the same ratio is found when we work out the scale factor. When we prove that two triangles are similar, we need to write what is called a similarity statement. And that's something like, therefore, triangle ABC is similar, so three vertical lines means similar, to triangle DEF. Or we could write, therefore, triangle XYZ is similar to triangle MNO, depending on the lettering and ordering of the vertices of the triangles. So the test for similar triangles, now not to be confused with congruence. So the test for similarities is different for the test of congruence. There are some that are similar, but there is an additional test that applies only to similarities, and there is a test for congruence that doesn't apply for similarities. But for this video, we're just going to focus on the similarity test. So the similarity test is when we have three sides the same. So side, 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 and not necessarily the same, but the same proportions, the same ratio. And that refers to that point there, the scale factor. So we might have a triangle. One is 4, one is 6, and one is 7. And then another slightly bigger triangle where the same lettering, the same corresponding sides is 8, 12, and 14. So they've all doubled at a scale factor. So times 2 scale factor. That's one way to prove similar triangles. Another test for it is side, angle, side. It's where we have two sides and an angle sitting between the two sides. Now the angle has to be the same. The angle has to be equal, but the sides can be in the same proportion. So an example of that might be if we have this triangle here, 11 and 5, and maybe we're given this angle in here, and then we have 22 and 10, and this angle there is also equal. So side, angle, side. For that one. Our next test, this is the one that's different to our test for congruence, and this one is angle, angle, angle. So when all angles in the triangle are the same, then the corresponding sides must be in the same proportion. That's just the way the three angles in the triangle work. It's a very unique shape in that sense. So all three corresponding angles are equal. If there are only two equal pairs, then the third pair must be equal by the angle sum of the triangle. So remembering that a triangle, all internal angles add to 180. So angle, angle, angle. The example diagram I'll use for this one might have this angle, this angle, and this angle. And then on a bigger model, it's the same. So then we've got similar because the angles influence the lengths of the arms of the triangle. The last one, and again this one's similar to our congruence test, is RHS. So when we have the right angle, the hypotenuse and another side. So if we were to have a triangle like this, hypotenuse of 5, side of 2, maybe 15 and 6. So here we have a scale factor of times 3. Those two are similar. In this example, we're given a triangle with a section line going through it. We're going to label this triangle ECA because that's going to be point B and that's going to be point D. We're going to say that's an unknown length, but we know that length DB is 2 and length EA is 3. We also know that these two lines are parallel. So for this pair of triangles, we're going to do two parts. So A, give a reason as to why they're similar, and B, find the value of X. So for this one, it's going to be triple angle, 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 angle. And I'll tell you why it's going to be angle, angle, angle. Because angle EAC is equal to angle DBC, since AE is parallel to BD. Okay, because that is parallel, or that the two are parallel, angle EAC, which sits here, and angle DBC, which sits here, are corresponding. So that is our F rule. Making sure we put our rule here, because that's your reasoning mark. And this symbol here, the double vertical lines, means parallel. So this is a shorthand way to write your reasons. So that's reason 1. That's our first A. Second A is that the angle AEC is equal to the angle BDC, since AE and BD are parallel. So angle AEC and BDC are also corresponding angles. Since we have those two angles being the same, then we can automatically assume that its angle C is also going to be the same. And in this case, it definitely is, because C is a shared angle. So for our second A, we had the F rule. In our third A, angle C is a common or shared angle. And that's all the proof we need. For part B, we need to find the value of X. So we're going to start to look for the scale factor. And in this case, the scale factor is going to be equal to 3 over 2. So dividing our smaller size into our bigger size, and we get a scale factor of 1.5. To find X, then we are going to multiply 5 by 1.5, and that's going to equal 7.5. And as I've done that, I realized that I haven't copied the diagram down properly for you. I'm reading off my notes next to my tablet. This measurement here from D to C, I should have drawn and given it to you. That's 5. That's where I got that 5 from. Okay, so that 5 is the length of DC. Then we multiply it by our scale factor to find the full length of EC. So X is equal to 7.5.